Thanks for having me. I'm part of civil engineering, civil and environment engineering. Excited to be part of the SDSS now for a year, a little over a year, because the challenges we face in the built environment really revolve around sustainability. And I think sustainability concerns require construction. So many sustainability solutions that we pursue, decarbonizing the grid, having buildings with less impact, and everything we do, most things we do, are in buildings, with buildings, and infrastructure, as we move around, etc. So the built environment is all around us. We can't really imagine a society without the built environment. And we partly have the problem we have on the planet because of the built environment. But we can't really live without it. And so solutions that make the built environment and our lives on the planet more sustainable, like decarbonizing the grid, will require massive construction. And if we do the construction the way we do it today, it will be simply too expensive and too slow. So that's what motivates me to work on the things I'm working on. So I want to tell you a little bit about where I'm coming from. I grew up in that yellow house there in the northeastern part of Switzerland, right at the border with Germany. And as we were building the house, I was 11. Like every client, like Stanford, we had more wishes than we had budget. So we kids had to help, my younger sister and I had to help building the house, little food tasks on the weekends. So that one Saturday, I was doing a job on the upper floor. So I did it, and then I said, "Dad, I'm done. Come take a look." And he come over and said, "Yeah, Martin, it's okay, but you could have done a better job if you had used this particular tool." I said, "Yeah, I know." And then he looks at me puzzled and says, "Why didn't you use the tool?" I said, "Yeah, Dad, the tool was in the basement, And that was just too much to ask of an 11-year-old on a weekend, to go down 2 floors, pick up the tool, carry it back up, and so I just muddled through. So to that explanation, this is what I heard from my dad. "You are an idiot if you're not using the best tool possible." So now you know where I'm coming from, literally, but also where I'm coming from in my mind, because this stuck with me, and this sort of motivates my work. And yes, tools are just tools, but they allow us to do much more as people. Like the tools are hugely impactful as we see in our daily lives. And that's what I want to do. Like VR is a fantastic tool, I think, for project teams to make better buildings in a better way, right? So that has motivated me. And then so one of the first projects I worked on was this bridge in Rhode Island, Jamestown-Verrazano Bridge. It was a fun project to work on, but I realized that I was, as a young, naive Swiss engineer that thought everything was well organized, I was a bit perplexed when I had this experience on this project, because we had to redesign the bridge so you could build it. I had thought, surely the designers know about design and construction, and they would create something that you can actually build. That was not the case, and I found later that is not the case. That's not the case with many projects. That we would have the information we need. No, not the case. Most days I worked half the time to find the information that I thought I would have. That the information would not conflict between the different disciplines. That we were actually pursuing the same goals across the different disciplines and companies. So those are my naive assumptions, but I learned very quickly that was not the case. And this is really what we are now working on to sort of overcome, because we still see these problems on projects in the university, everywhere, small and big. And that has also motivated my work here. This experience motivated me to come back to Stanford, do a PhD, and stay on. So, as I said, the construction industry creates the fixed physical wealth of nations. We can't really live without it. We can't really imagine a society without it. But it's a huge industry, 14 trillion a year globally. And so in other industries say, it's a $500 billion market. I'm like, huh? Yeah, okay, that's nice. Sorry. But there's also a lot of bad news. So I want to give you a little bit of motivation why we do this work as well, why it's important that we do it. One sad fact is in the US, every workday, about 20 people get killed on construction sites. It's crazy, like 5,000 a year. It's way too many, right? It should be zero, of course. You see headlines about delays and cost overruns around the world. We produce way too much construction demolition waste. I mean, it's gotten better, but by my back-on-the-envelope calculations, just by living in this country, I'm producing 0.5 ton of construction and demolition waste. I mean, not personally, but as part of the society, every year. We produce much less garbage than that at home. We don't have 1.5 tons of garbage, but by living here, that's the whole system. It's crazy. Again, a very back-of-the-envelope calculation I did a few years ago. The embodied, the energy needed to produce this material that we just throw away could provide the electricity for California for a year. It's just staggering what we can afford to do, right? I mean, it's a very back-of-the-envelope calculation, but you get kind of the idea. It's crazy. The value-added time on projects is, roughly around 50%. Huge potential. The workforce is getting old. Building sector generates about 40% of carbon emissions. Construction activities about 11%. So that's what I was alluding to earlier. That we need to get better. Our ability to predict the performance, especially for energy performance, is not great, as you can see with my Swiss understatement. Basically, what you see here is a bunch of buildings. Each dot is a building. And this is for buildings where the clients actually cared about the energy performance. And so the line, there's no pointer, so the line, the 45-degree line that goes up, that's where the buildings should have fallen if the predictions were right. And you see some buildings above the line, they did actually better. But you also see some buildings below the line, and then you see some buildings very low. They're even worse than code, even though they wanted them to be better than code. So, but you see, basically, if you didn't put the lines there, you would ask, what is this, right? No rhyme or reason. So our ability to have the information we need in projects to make decisions is very poor. And that's a big thing we're working on is basically, it's because we don't have very good feedback loops. And that's what we're working on to have those available in our industry. I mean, the challenge is, right, every project has a unique aspect to it because there's no other building or infrastructure built at that time in that location with those requirements by those people, et cetera. And so that is a scale of sort of observation that has been difficult to do. And that's why we work with these kind of poor models, because we haven't been able to orchestrate these feedback loops over time. But of course, as you can imagine already, with digital methods we have now, that is changing. And at the end, the value is added on the site. Unless somebody puts something in place, a solar panel in a solar farm, or a better insulation on a building or something, there's no real value added to what somebody wants. But again, that's a very distributed work. There's hundreds of thousands of companies in the US alone that do this work that we have to reach to create better methods. So in a nutshell, I think because of many of these factors, productivity in construction has been stagnant for 100 years. Not something I'm proud of, but that's what it is. That's value add per work hour. Other industries that make things like manufacturing have gone up. Our industry has been stagnant. And I don't know if you listened to Freakonomics. This was actually a very recent Freakonomics podcast, so it seems to be noticed. But again, the issue with that is we need to build a lot of things like solar power plants, wind farms, upgrade buildings to make our built environment more sustainable. And with stagnant productivity, it's not a good story. But I think we have a blueprint of what it will take to make things better, at least I believe. We can just look at what has the manufacturing industry done to make its production much better, much more value adding. And basically, compared to over the last 50 years, you wouldn't dream to be a world-leading manufacturer if you didn't have full digital twin replica of what you're doing. If you didn't really think about design for manufacturing and assembly, like design for constructability, like I didn't experience on the bridge. If you didn't have statistical process control, really knew what was going on, and if you didn't have feedback loops in terms of how good is your design. And these are all things that we can now, thanks to digitalization, bring to our industry. But it requires fundamentally different models, I'll just leave it at that general term, of our work, which we don't have. And that's really what we look to do in our research. So I'll give you a couple quick glimpses of that, very quick, just to have an idea of some projects going on in my group. But the basic idea is that with data-driven methods, we can figure out from the past projects, what is it that we actually like? Because some things are good, but we have had a difficult time to scale that. It has taken a long time because it's very anecdotal how we learn in our industry still. And so to convince everybody like that was a good experience and this is how you do it is extremely hard to scale anything. But with data-driven methods, we can start to really understand in terms of building performance, construction performance, all aspects of performance, what actually worked, what did we like. So then a group of people with virtual reality, exactly, can take those experiences, simulate possible futures, so that they can pick the building or road or whatever they're making that they actually really want to create. I mean, we're not there yet. This is still very much an experience-based approach today that you find on projects where a group of people gets together and says, yeah, I think this is good and this is good. I mean, slightly better than that, but it's essentially that. But we're working, not only me, many of us in civil engineering, to make that possible. So for that, we have done a whole bunch of projects, are doing a bunch of projects, like Eero Armeni, together with Silvia Soares a few years ago, did the first project that allowed us to go from a scan, a laser scan that you can take, or 3D image, to actually information of a project, of a building. We have studied what does it take to actually really optimize a building. That's together with my colleague Eduardo Miranda, where we created a method, well, PhD student Filippo created a method to fully automate the design of a structural steel system for a major building so that you can then optimize it, not only for material, but also erection and fabrication cost. It was interesting to see that on an actual project, they saved 10% of the cost because we could make much better details. And so by making things in parallel in a traditionally sequential design process, we could find those savings. We are able to show that by leveraging sensor data that tells you, for example, what a crane is doing every second, we can make better decisions, use the resources inside much better. So I'll go quite quickly, but this is what the company Clark Pacific that also built the EVGR. And basically, they have to predict every day what to order from their precast yard. So precast is a great method to build projects faster and also in many ways more sustainably, or offsite fabrication. And they, so they have to order every day the parts for tomorrow. On average, they were 2 hours off. So they had 2 hours of overtime or 2 hours of wasted capacity, even though they really tried, and they're a really good company. So what we then were able to show by leveraging this crane hook, the data about what the crane is doing every second, totally different way of managing project, and sorry for the crazy graph here, but basically the gist is if they had ordered the perfect number of parts each day, from left to right you have number of work days, all the dots would fall on the black line in the center. And then but the gray lines is what they ordered. You can see many times they were far away. And the colored dots are, if they had used the data, they could have made a much better prediction. They could have saved, they could have made a 50% better prediction. We're studying how robots help construction teams be safer, more productive. together with Usama Khatib. So this one example of a robot, a drilling robot. Basically what we've seen by studying quite many robots in many different parts of the world, that, to come to the gist of it, robots have always improved the safety and the quality of work, and the story is a bit mixed on the cost and schedule impact. But I think for first versions of these robots, they're brand new, that's quite promising performance. So I'm pretty excited about that. Using ChatGPT, something like it, to talk with the information basis. There's lots of information about buildings, but it's difficult for the people that really need it, like workforce, to access it. So, and we've been able to show that we can make that possible with the latest language models, a little bit of training. And last quick snippet, one of my PhD students is a Stanford Living Labs fellow, and she's working on the policy to decarbonize the embodied carbon of our buildings. So that's very exciting. So there's a few, I also work with business school to develop management frameworks. I just want to mention that, just as a quick pointer of possible collaborations together with Robert Bergelman. But hopefully that has given you a glimpse of the kind of work that goes on in my group. Basically, it's about making better decisions today with better insights about the past, the future, and what technologies can do. And yeah, I'll skip over this slide because I need to wrap up. Because I want to wrap up with the environment I need for this is, as you can see, as we have to get very deep onto projects. I can't ask for the money for a lab. I need a lab here that allows me to build a building 10 times to figure out what's the best way, and then we do it right the 11th time, right? That would be silly. So I have to be able to get the trust and access to project teams to really get deep into what they do. Otherwise, we wouldn't have been able to do what those projects I quickly showed. And for that, we have the Center for Integrated Facility Engineering that I run. Basically brings together innovators from leading companies so that we don't have to reinvent the wheel in terms of the things they're already doing. And we have an avenue for our research to have an impact. And we put all of the things we've put together into a framework, which we are out teaching together with SCPD to professionals around the world. It's another important part of enabling this, because without this professional education, it takes too long for, again, the things we find out to reach the market, and then there is no basis for me to do further research. Because it doesn't do me any good to do research on practices that are like a generation or two back in terms of their technology, for example. So this is, just wanted to share a little bit of this ecosystem that I depend on, that we created, and that we have to keep going if we want to keep doing this kind of work at a fundamental theoretical level that also has impact. So yeah, that's a few of these professionals we're teaching around the globe. And today, if you listen to the Freakonomics thing, you will see if you build it, they will complain. I can't take that's in the Freakonomics thing. It's sadly true, but of course what we want is we build it, they will thrive, and they really meaning people, nature, together. That's of course the vision we have. Not only me in my group, but also in the department. So thank you.